Everybody, in this video, we're going to look at how to simplify complex rational expressions. So complex fractions or complex rational expressions, are basically when we have a fraction in a fraction. So for instance, just going back to your regular fractions, let's say you had something like 1/2 divided by 3/4. This is a complex fraction. So there's different ways that you can do it. But one way is to remember that this is a division bar. Okay? So this is the same thing as having 1/2 divided by 3/4. So what we end up doing, again, this is one strategy. I'm going to show you two different strategies for rationals. For fractions, this is probably the easiest strategy. You leave your first fraction the same, change the multiplication, and then don't forget you flip or take the reciprocal of the second fraction. And then you can keep multiplying from there. So what happens is you end up just basically flipping or taking the reciprocal of the denominator. And that's the way that we can clear them out. So for rational expressions, again, there's two strategies I'm going to show you, but one of them has to do with the same exact strategy that we're seeing here. So for example, we want to simplify something like 1 plus 1 over x all over 1 minus 1 over x. And I'm just going to call this strategy 1. Okay, so just kind of using the skills that we already have on how we can simplify this. So using this idea that this is a division bar here. Now, there's a problem in this case, and that's because I have plus or minuses. In my original example here, I just had one fraction in one fraction. So you do need to make sure that you do simplify first and make sure you have just one fraction in the numerator and one fraction in the denominator. Okay, so I'm going to take a little bit of work off to the side here, and I'm going to simplify my numerator and denominator. So think about 1 plus 1 over x. We're adding. So here, this denominator would be 1, and then you'd have to think about, okay, I need an LCD, which would be x here. So what you would do is you would multiply by that missing piece for that first expression here. My second expression is fine because I already have the x in the denominator. So this becomes x over x plus 1 over x, which is x plus 1 over x. So my numerator becomes x plus 1 over x. And again, now it's one fraction all stuck together. So that's what I want. And I'm going to simplify my denominator. So 1 minus 1 over x. My LCD, again, is going to just be x here. That's really my only denominator. So I want them both to have x's. So for the first group, it's 1 over 1, and I'm missing that factor of x. So I end up with x over x minus 1 over x is x minus 1 over x. Now, notice that I'm using skills that we've learned in previous videos, right? We already know how to add or subtract rational expressions. So you need those previous skills in order to be successful here with complex fractions, which are obviously more complex and more complicated. So our goal here is to simplify that numerator and denominator first to make sure that it's all one fraction in each case, because I need to be able to flip it. So now what you do is you can rewrite this. So this is the same thing as x plus 1 over x. Again, this is my divided by line, divided by x minus 1 over x. So your first part stays the same, and then you flip your second fraction. Now you're multiplying here. Everything is already factored. I don't have any squares. I don't see any common factors or anything here. So I'm just going to rewrite the numerator and rewrite the denominator and cancel what is in common. So I have x plus 1 over x minus 1. So this process here of actually rewriting it as division and then multiplying and flipping the second fraction, again, that part's not too bad. We've already learned how to divide. So we know how to do that. We're okay with that process, right? So we do know how to do that already. But it does take a little bit of work to sometimes simplify those numerators and denominators first, particularly if you have a lot of adding and subtracting or more complicated problems. But we can do it. So this is going to be our result here as our final simplified form. Now, when you're looking at your denominator here, these can actually get pretty tricky because you have so many different steps along the way. So kind of start at the beginning. So think about what's going on here. I have two denominators. I have this one and this one. They both happen to be the same. So that's kind of good, right? So I do need to make sure from here that x is definitely not equal to 0. As I go through, I see I have actually the same denominators, right? So still x and x. And it's not until kind of here where I start flipping things around that I get a different denominator. So I do see another denominator here, and I need to make sure that this is not equal to 0 as well. So I'm excluding 0, I'm excluding 1. So when you're looking for rationals, check all your denominators first. Make sure none of them is 0. Then you have to also check the little kind of oddities that pop up. So remember, for dividing, we need to make sure that when we're dividing that our numerator is not 0 as well. Again, that's unique to dividing. But here we've already done this one. X is not equal to 0, x minus 1, excuse me, when x is 1. So we have that one already. We end up seeing that in our denominator in the next step. So we do have that one here. And then the other one you have to look for is technically this whole thing is a denominator as well. So I do need to make sure that this is not equal to 0. When I subtract 1 from both sides here, I get negative 1 over x is not equal to negative 1. If I divide those both by negative, I have 1 over x is not equal to 1. So what happens here is the only way to have this equal to 1 is if that x is also 1. So this is telling me that x, again, cannot be 1. So I already have this value. And again, like I said, these are complicated. They're called complex for a reason. So you have to simplify them, and then you also have to check a lot of different domain issues here, excuse me. So always check all denominators first. So here are obvious denominators, right? And then here's an obvious denominator, right here. Make sure this is also its own denominator, right? Because we have a denominator within a denominator. So this has to also not be 0. And then unique to dividing, that numerator of the divisor has to also not be 0. So there's quite a lot of things to check here. But for this particular problem, we have two issues. We need to make sure that x is not 0 and that x is not 1. So those are going to be the domain, the two main pieces for our domain here that we are watching out for. All right, let me show you a second strategy here. And I would say that probably most students like this one better. So I'm going to rewrite the problem. So what you do in this case is you find the LCD of all denominators in the problem. And I just mean, I don't mean this overall one here. I just mean like all the little mini fractions are in the problem. So if I have two denominators here that I'm looking at, x and x. So my LCD here is just x. And then what you do is you multiply both the numerator and denominator by the LCD. So I'm going to multiply the numerator by x and the denominator by x. So I'm still just multiplying by a factor of 1 here like I have been doing, but I'm multiplying on the top and on the bottom. Now what happens here, I'm just going to rewrite this so you can kind of see, is that when you do this, you're going to end up distributing that x to both parts. So I'm going to multiply it through. So 1 times x is x. And then here, just be careful. You have 1 over x times x, which is x over 1. So you get x over x. And x over x is just 1. Similarly, here you have x, and then you're going to get a minus 1 over x times x. So those x's are going to cancel, and you get a 1. Now you can see here that we have the same exact answer that we did up here. So this strategy tends to probably be the most preferred strategy for students. It does tend to be faster. I don't know if it's as intuitive as the other strategy where we kind of know how to divide and do all of that already, but you have that same basic idea here. And this one, of course, would have the same domain issues to watch out for since it's the same problem. All right, let's do another example or two. And for the next two examples, I'm going to focus on strategy 2, because like I said, I think that one tends to be the most preferred strategy for people. It tends to be faster, but you would get the same answer with strategy 1. So if you like strategy 1 and just kind of doing the regular division and adding and subtracting, try it out and make sure your answer matches. And if you have questions, let me know. So for strategy 2, you need the LCD of all denominators. So I have a denominator here and I have one here. Now, I mean, when I say denominators, I don't mean like this H here. I just mean like the fractions within the fraction. So those denominators that are the ones that we're looking for. So I have one factor here of x plus h, and I have another factor of x. Those are different, so I do need to include them both in my LCD. So I'm going to multiply both my top and bottom by these two factors. And I'm actually going to rewrite it like this. I think it's a little easier to read if I put that x out front. So I multiply the top by my LCD and I multiply the bottom by my LCD. And I'm just going to do a little bit of rewriting here. So I have 1 over x plus h minus 1 over x is being multiplied by x times x plus h. And in the denominator, I have actually just h, excuse me, times x plus h. So let's go ahead and write this out. And again, this is, even though it's an easier strategy, it's still pretty messy. So as you distribute, you may want to write some work out off to the side. So I'm going to actually take my time here for a second. So I'm doing x times x plus h, and I'm multiplying that by 1 over x plus h. And then I'm subtracting, I'm doing x times x plus h, and I'm multiplying that by 1 over x. And in the denominator, hx, I can just write as hx, and then x plus h here, just to clean that up a little bit. Now watch what happens in the numerator. The whole goal is so that we don't have these messy fractions and fractions. So notice how the x plus h here and here are going to cancel. And then you have an x times 1 left, which is just x. Here, the x and x are going to cancel. And then you have the x plus h times 1 left, which is just x plus h. Now be careful, you cannot cancel anything yet. You do have to finish distributing and cleaning this up. So x minus h. What ends up happening is your two x's end up canceling here, and you're left with just negative h over h times x plus h. So I can cancel the h's here. If you have nothing left, there is a factor of 1. So my final answer is going to be negative 1 over x times x plus h. You can also write it with the negative out front. So if you want to, you could write it like this, just as a side note in case you write it a different way. They're both the same thing. Whether you have the negative up top or you have it out front, it doesn't matter. You have the same answer here. So that would be the simplified problem, again, using strategy 2. Now, again, the big thing to watch out for here are all those domain issues. You have quite a few domain issues here. So think back, I would just go back to the original problem first to see all those denominators. So you have one denominator here, Another one here. And actually, you do have one here as well, right? Because h actually is a denominator. So x cannot be 0, h cannot be 0 in this case. And here's a weird one. This factor can also not be 0. You have two different variables here. So when you plug things in, you have to make sure when you plug both numbers in, you're not creating another way to get 0. So if I solve here and subtract h from both sides, I do see that x cannot equal negative h, meaning that they can't be opposite values of each other. So for our domain restrictions here, we actually have 3. We have that x cannot be 0, h cannot be 0, and x cannot be equal to negative h. So that's a really different way to think about this, because your last restriction is not just a number restriction, it could be anything. So when you pick two values, x and h, to plug in, you have to make sure, for instance, that if x is 2, then you can't let h be negative 2, because what happens is you create a 0 on this first fraction. So you have a more complicated domain restriction here to watch out for. All right, I want to do one more example. Let me get a new piece of paper. Oh, and I should say too, I'm sorry, I kind of skipped ahead. When you're looking for your domain restrictions here, I went back to the original problem, but also if you check the ending ones too, you end up with the same domain restrictions. So I'm just pointing out that there was nothing else that came up throughout the problem that I didn't already have from the beginning. All right, let's do a hard one. All right. So here we have, again, a really complicated one. We have a fraction within a fraction. We also have squares and things here. So if you're dealing with rationals, I would get rid of that square first by factoring. So before I even start thinking about anything else, I'm going to factor this here. So my other terms I can't do anything with, but I can factor that one. So it's going to be x, and then 3 and 1. And let's see, we're going to make the 3 a minus and the 1 a plus. And I'm going to focus again on strategy 2 here. Since that tends to be the more preferred strategy, it is a little bit faster. So what you need to do is you need to find the LCD of all denominators. And again, by denominators, I mean the fractions within the fractions. So here's one, here is another, and here is another group. So I've found 3 sets of denominators here. So I definitely need the x plus 1. I definitely need the x minus 3. Now here I have the same factors again, x plus 1, x minus 3, so I don't need to write them in again. And then what I'm going to do is I'm going to multiply this with my numerator and my denominator. And the reason we're doing this is our goal is to get these extra fractions to cancel out. We just want one normal looking problem, one normal looking fraction. I don't want fractions here and fractions everywhere. So the goal of this is to get all those extra fractions to cancel. Now, you do have to remember that you are distributing this. So this is going to this piece, and then this in the bottom is going to both of those fractions. So I do like to take my time and rewrite this. So in my numerator, I have 1 over x plus 1 being multiplied by x plus 1, x minus 3. In my denominator, I have my first fraction being multiplied by x plus 1, x minus 3. And then I also have the second fraction being multiplied by x plus 1, x minus 3. And you should notice that all the extra fractions should cancel. So x plus 1 cancels. That leaves you with just x minus 3 in the numerator. Here, x plus 1, x plus 1, x minus 3 cancel. Do be careful. You still have a 1 here left. So I'm going to just write that 1 in. And then I have a plus sign. Here, x minus 3 cancel. And I'm adding in that x plus 1. So if I clean this up a little bit, I have x minus 3 on the top, 1 plus x plus 1 on the bottom, and I get x minus 3 over x plus 2. Those cannot be factored any further, so this is going to be my final result. Obviously, much, much nicer looking than the original. All right, so let's check our domain here. Again, this is the hard stuff, I feel like. There's just so many denominators. All right, so whether you start at the end or the beginning doesn't matter. Check all your steps throughout. Make sure you haven't missed anything. So in the beginning, I have so many different denominators here. I have the x plus 1. I have this one. I have this one. This one factored into x plus 1, x minus 3 as well. So I have two main issues right here. I have that make sure that x plus 1 is not 0 and that x minus 3 is not 0. So I need to make sure that x is not equal to -1 and x is not equal to +3. So those are two domain restrictions that I find from the original part of the problem. Let me zoom out a little bit so you guys can see all of that at once. Okay. Now, as I'm going through and I'm multiplying and things like that, I end up with a new denominator at the end, right? We don't have this factor yet. So I do need to make sure that this is also not equal to 0. So I have a third restriction here of x is not equal to -2. Okay. Now, there is actually one more thing you can check here, and this itself is its own denominator. So you'd want to make sure that this whole thing overall does not equal 0 as well. But I'll tell you that you don't really have to worry about that one because it ends up coming out at the end in the same denominator here. So there's a little note. I'll show you what happens. You have that 1 over x squared minus 2x minus 3 plus 1 over x minus 3. And you need to make sure that this is not equal to 0 either. Well, that first part we saw factors into x plus 1, x minus 3. And then what you would do here is you would use your LCD of x plus 1, x minus 3 to go ahead and add these together. So think back to how do you add rational expressions. This first term is not missing anything, so it's going to stay just a 1. But the second term is missing the x plus 1 term. So you end up multiplying that group by the x plus 1 term. And what you're going to get when we combine this all together is 1 plus, now this 1 is going to distribute x plus 1 over your LCD. And we had that same x plus 2 in the numerator that we had in our final answer equals 0. So to solve something like this, and again, I don't want you to worry too much about this because it works itself out in the end here, is you would multiply by the LCD on both sides. Just like if you had a regular fraction problem for an equation, you would multiply by that LCD on both sides. That would allow you to cancel it on the left and move it to the right. And what happens is, well, when you multiply by 0, this whole thing cancels. So you end up with the same denominator that we had at the end in this problem. So you do have that added restriction, but like I said, it's going to work itself out. So as long as you're checking your denominators along the way, I don't think you're going to have an issue. I think you're going to catch all of the potential issues by looking at the individual denominators in the problem, and then again, your final answer and those steps along the way. If you do everything right, I think you're going to hit all the possibilities and you shouldn't miss anything. But these can be tough. So you have to watch out for all those denominators and really just take your time here when you're simplifying them.